Okay, so just whilst you're finishing off that last one, can I just have a bit of attention, please? So I want to kind of illustrate what's actually going on here, because I've very deliberately given you examples which involve a context, because if I didn't, I can promise you that what we are doing here will not make sense. Okay, it just will not make sense. You'll just remember it as a process and you'll hate me forever. Okay, whereas if I can put it in context with you, then hopefully you're deriving what I need you to do yourself, because then you'll realise, actually, do you know what? This makes total sense. So here is the idea. A matrix is specifically a table of numbers. But I have given you these numbers in terms of, in the context of in terms of sandwiches and the cost per sandwich. So what I'm asking you then is what happens if I remove that context? What happens if I just gave you this as one table of numbers? Okay, so I might put a bracket around them to illustrate that it's one table of numbers. Okay, and I gave you this as another table of numbers. So I got rid of this, all the context. I just gave you this as another table of numbers, another matrix, okay? And my question is, well, what would I have to do in order to get this last matrix here? Okay, so again, I'm just removing all of the context from this. Now, what you have done here is you have combined these two tables of numbers through multiplication. Okay, so what I'm literally doing here is I am multiplying these two matrices together. I'm multiplying these two matrices together. So I'm taking this matrix and I'm multiplying it with this matrix and I get this matrix. Okay? This is what you have been doing. For these last three questions, this is what you have been doing. So let's just reiterate how we actually go about this. So what I'm trying to say to you is that you do not need a context. You can still multiply these matrices together even if they didn't know what the context was. They were just tables of numbers. They could represent anything. Okay? This is how it works. First of all, we need to understand what we mean by the dimension of a matrix. Are you happy that with a matrix you have rows, okay, they go across, and you also have columns, which go up and down, okay? So what is the number of rows in this first matrix?
5.
It's 5 rows. Are you happy? Like 1, 2, 3, 4, 5, okay? How many columns are there in the first matrix? There's 3. So I would describe this first matrix here as a 5 by 3 matrix, okay? Because there are 5 rows and there are 3 columns, okay? Now just be careful, the rows go across, okay? The rows go across. So imagine like you're looking across like almost like shelves, okay? Shelves which go across, there's 5 of them and there's 3 columns like that. Don't get confused. Like don't go that way if you like. So don't say, oh right, there's 3 rows because I'm moving from left to right. Don't do that. Just think of them almost like shelves. Okay, one stacked on top of the other. What are the dimensions of this matrix here?
3 by 1.
3 by 1, perfect. Okay, and what I am doing is I'm taking these two matrices and I am multiplying them together. I'm multiplying them together. Now, the reason why I can multiply these together, because you might take some matrices which just don't work. For example, if you had, I mean, this corresponds to days, right? The rows correspond to days. So you might have 5 days and 3 sandwiches. That's how many columns there are. Then over here, you might have, say, 6 sandwiches and 1 column. Then you couldn't combine them together. Are you happy with that? Like you couldn't combine them together because in this case, you'd have a different number of sandwiches. You wouldn't know how to combine them together. So you must make sure that the number of columns, in other words, the number of sandwiches in this context, corresponds with the number of rows in this matrix. Are you okay with that? Okay, so you're making sure that that thing is the same as that thing. So this number of columns must correspond to these number of rows in the second matrix. Yeah? Now what is the dimensions, or what are the dimensions, of the resulting matrix? So what's the dimensions of this? Yeah, good, 5 by 1. Okay? And you notice that that 5 by 1 comes from the fact that you had 5 rows in the first matrix and 1 column in the second matrix. Okay? So what I'm trying to show you here is that even before you do this weird thing called matrix multiplication, you were able to identify, number 1, can you do it? In other words, do the 2 inner dimensions match? And also, what is the resulting matrix going to be if you can multiply them together? So the resulting matrix will be that and that. Those are the dimensions of the resulting matrix. So this one is 5 and this one is 1. Does that make sense? Like how you identify the dimensions and whether you can multiply matrices together?